ask me anything, okay? Let's say you cannot enter the quiz. Okay, every one of you can enter the quiz. Okay, right. So please try to do it. There is no marks, don't worry. I just want to see your focus and your understanding throughout our class yesterday.
Excuse me, teacher.
Yes, yes.
I cannot find the quiz.
Huh? You cannot
At
find the quiz?
e-learning.
Yeah, at e-learning.
Sorry, I don't have.
Uh, your section is what?
Wait. Section 9.
Yeah. Let me see. Let me. Ah, no. Okay, this is section 9. The quiz is at our 25 October. Here, below the video for module 01, part 1. Can you find it?
No.
Huh? Can you share your screen?
Wait.
That is 00. That the one that you share is the section 00. Can you go to the home?
But my
Go to the home
UTM,
first. No, go to the e-learning home. E-learning home. There is a home icon at your left. Okay, there. You can just scroll down. Scroll down. Where is your course? There is a cap. The graduate cap there. Can you just pointing out your mouse to that icon
wait,
at the
sir.
left, at the left side? Yang macam topi graduate tu. There is a section 09. Tak pernah masuk e-learning ni. Nota pun tak ada lah ni.
Tadi tak ada.
Ada. Okay. Pulang.
Okay, sir, thank you.
Hmm. Okay, you have another about 6 more minutes or 5 more minutes. For those who already finished, you can like just submit it. But by default, although you did not submit, it will auto submit once you reach at 48. Okay, another 3 more minutes. Okay, 1 more minute. Okay, let me see your performance. Yes, 7, 5, 4, 3, 2, 1. Let me see who's at the highest. The highest, 1, 2, 3. Okay, there is 3 students. Khairul Izul Firdaus, Lai Kai Chian, and Muhammad Adib Wafi. All of them get 15 per 17. So only 2 question wrong. Let me check. The lowest is 8. The lowest is 8 per 17. So only 1%. Minimum others is like 8 to 11, and only 3 get 15, and the rest is 14. Okay. Now I just want to share with all of you. I did this simple quiz with other section 2, which is section 3 and section 6. For section 3, there is no format. I guess because I teach them first, which is like last week, and then just this week I did the quiz. And then for section 6 also I did the same. But there is one student get full mark. And then I asked the student, what is your, not trick, what is your, what what is your tips? What is your tip? How you can get full mark for your quiz? And then he said, because he just joined the class like yesterday, similar with all of you, which is you just learned yesterday, and then he watched the video, he read the modules. So the purpose I did it like without telling you anything related the quiz. I just like very quick and short. So sudden to have this quick quiz. I want you to be prepared not only for any subject, but also in your life. In our life, there will always sudden like accident or any kind of thing that might come up throughout your like current life, let's say. So example, maybe if you can apply this kind of thing, maybe your lecturer said, okay, your quiz will be held on 10 October, 10 November. And then he said, okay lah, I will study at 8 November maybe, but there will be something happen to the school, to the university, and then suddenly, and also the lecture itself. So the lecturers cannot handle the quiz at 10, and then after 10, he been busy, so he need to like make it earlier. Then you will like having difficulty if you not prepare earlier. And in life, let's say what happened to like this current situation, which is COVID-19. If let's say like you get the salary, and normally like you will like feeling okay, it's okay. I feel comfortable because every month, I will get salary. Every month I will get salary, of course, because you already like terbiasa. You will like okay lah. Every month I will get salary, so no need for me to worry. I will like do the saving next month maybe. So you wait for next month, until suddenly COVID coming up, and you will have you will face with the trouble for your financial. Maybe you will be suddenly been kicked from your company, or maybe because of COVID you need to have like strong financial, especially maybe some of your children or some of your family member are warded. So yeah, you cannot go to like government hospital, so you want to save life. So that's why maybe you like, okay, I need to go to hospital swasta, but it's quite expensive. So if you don't have saving, if you didn't prepare earlier, so you're going to have trouble. Same goes to what happened in this quiz. after your class when you have free time, why don't you just like prepare any kind of subject, just read and just be prepared, anything might happen. Okay, so this is a lesson for you, and I'm going to go through and check your marks, and especially because I can see which question that you get wrong. So I will like see the average question who still did not understand the question. Maybe I will like recap a bit, because I can see over here most of you didn't get correct for like question 3, maybe question 3 and question 4. There is a lot of, the percentage is quite low. It's okay, later on I will double check. Now we're going to start our class, and I still can see a similar name like yesterday, still not yet turning on the microphone. Tech, you did not turn on your webcam. Okay, I'm going to share my screen. Please just interrupt me whenever you feel like you need to know anything or you want to share anything. Just interrupt me, okay? Okay, yesterday we already learned about basic gates. So about basic gates, we already looked into AND gates, O, and also NOT. Please try to like just share anything that you might think useful to share with your friend. If you like doing nothing, you should just hear, and then you will feel bored. I will also feel bored teaching like this subject is very not active if compared to other sections. So please just have fun in class. So just like talk anything that you want to talk, okay? Okay, yesterday we also see on the truth table. As I mentioned, this is like your first time yesterday in your class you heard about truth table. And for this truth table, you're going to have the input and also output. For the cases of your NOT gate, you will have only one input. Did I record? Yeah. Did I click the recording? Yes, right.
Yes.
Okay, thank you for answering. Okay, over here you can see there is only one input and only one output, and we know it as the inverter. So whatever input, it will invert the value. If it is high, it's going to be low. If it is low, and then the output will be high. So this is how the way you draw the truth table. upon not. But later on, you can see also there is like this kind of truth table. Here is your Z or Z, over here is your output. This one is your input. 0, 1. 0, 1. This means that this will be your input 0 and this will be your input 1. So for input 0 for X situation, your output will be 1. So you will put 1 here. So why you put 1? Because this one is like active high situation, there is no active low. And what can say, okay, later on you will learn on POS and SOP. So all of this require you to use this truth table, not this one. And for your Boolean expression, to make the Boolean expression also you need this kind of truth table. And if let's say you have the input 1, your output will be 0 over here. So you will have like having this kind of truth table, the rest will be 0. And how you're going to get like your Boolean expression, you will do the circle. Later on, you will learn how to make these things. But I just want to share with all of you, instead of this truth table, later on you will use this truth table, this kind of your truth table. This is just the representation. If 0, what is the output? If 1, what is the output? But this is you going to use for your Boolean expression, for your POS and SOP. And there is also a thing which is you going to put, instead of 1, you will put the 0, especially for your SOP.
It's 9 hours.
Okay, now go back to our slide here, which is our current. This is the example for IC 7404. You can have several other IC, but because this IC are apply get node, so just want to see how and where you can apply your gates. Over here, this is the gate N. And I already mentioned you that our gate N will have the minimum input of 2. So you cannot have this version of gate to be N gate because you cannot have only one input. You need to have at least 2 input to be the N gate. And this is the truth table for your representation. This one is your output, this one for your input. And you can see yesterday, I guess yesterday, did I teach it or not? Forgot already for this class. Okay, there is a condition which is for your not get. You have only one input. That's why you have to the power of n. To the power of n means that n will be your input. How many input you have? If you have 1, then you will have to the power of 1. So there will be 2 condition or 2 possibilities that only available. So you only have 0 case or 1 case. So if whether your condition will be 0 at your input or your output will be 1. While for your 2 input, you're going to have to the power of n will be 2. How many condition or scenario that you will have is 4. So to the power of 2 equal to 4 means that you have 4 possibilities. So what is it? It is 0, 0, 0, 1, 1, 0, 1, 1. What is this represent? Is if your input A and B condition like this. one condition you can have A to be 0, B also 0. Another, A is still remain 0, but you change the value of B. And then you change the value of A, but the B will be 0. And then A remain 1, and then B will be changed to 1. So you cannot have any other condition. There is no other possibilities for you to have. So that's why it's only 4. And I already mentioned you, this is on binary. Later on, you will see that you're going to learn numbering system in your module 2. And in your module 2, you will learn binary, how to convert to decimal. And if it's 0, 0, your decimal will be 0. This one is 1. This is 2. And then this is 3. If let's say you have 1, 2, 3. If you have 3 input, what will happen? You're going to have to the power of n. Your n will be to the power of 3 because you have 1, 2, 3 input. So because of this, you will have 8 possibilities or 8 scenario for your input case. You cannot have more than that because that is only scenario that will be available. What is the scenario? You're going to have 0, 0, 0. Let's say your input is A, B, C. You can have all the variable A from Z to be your input and also your output, depend on the condition. Then you can, like A, B still remain 0. You change only the value of C. And then you have another one. You change the value of B. This one will be 0. And then you remain the value of B. A still remain 0. And you change the value of C. Then because of A and B, B and C already changed, you change the value of A. And then you play around with the value. I guess this one is more on mathematical. So all of these basically is 0, 1, 2, 3, 4, 5, 6, 7. All together 8 scenarios. And if let's say you have 0, another one which is let's say D, you will have to the power of 4 equal to 16. So you're going to continue with this. And continues until 8, 9, 10, 11, 12, and you will get until 15. So how it's going to be that? Okay, now let's see you have 0, 0. This means, because as I mentioned, this is binary. Binary is base 2. So you will use like 2 the power of n, which is first is 0, to the power of 1. This is our numbering. If let's say you have 3, let's say you have 1, 1, 1. This is your to the power of 0, to the power of 1, to the power of 2. And if let's say you have fraction number to the power of -1, to the power of -2, over here it will be negative, but all of this you will learn in your numbering system. Only that I want to show all of you why you will get this kind of value. Sometimes you might confuse. Okay. Now you can see over here. If let's say you have 0, 1. What is to the power of 0? As I already mentioned, every number, if you have to the power of 0, you will get 1. So because the value is 1, this one, you need to times 1. This 0 to the power of 1 will be 2. 0 times 2 will be 0. 1 times 1 will be 1. You plus, you get the value of 1. This is in hexadecimal. Normally, you don't put the, this is the decimal. Normally, you're not going to put the 10 base. But our numbering system is decimal, which is base 10. If let's say there is another example, you have 1, 1, value of 1, 1, which is over here. It means that you have to the power of 1 to the power of 1 and 0 equal to 1 equal to 2. This one is times. This one is times. Then your answer will be 2 plus 1 equal to 3. So that's why this is 3210 in decimal. And this one is in binary for both input. So for n, we only will get 1 if both of our input is 1. If let's say I have many input, 0, 0, 0, 0, 1, 0. Sorry. Terbalik pula. I have 1, 1, 1, 1, 0, 1. Suddenly, only there is another 1. But the rest is another 0. But the rest is 1. So what is my output? Is remain 0 because I need to have all 1 for n condition. Okay. Now let's take a look into our O. For our O, we will have 0, 0, 0, 1, 1, 0, 1, 1 for our XY for the input, and our Z will be the output. For this case, we already learned that if at least one input is 1, then your output will be 1. So you can see over here, this got 1, this got 1, this got 1. But this one, no 1, so it's 0. So this is how you know the condition of O. From this basic thing, you need to understand first. If you go forward later on, you will get difficulty if you don't know the basic. So now I want someone to teach us what is okay. Let me find someone that can teach. Alif Aizuddin. I will share you one simple circuit. I just want to know the output, okay? Although I basically don't know what is the answer.
Alright.
Okay, I will draw my circuit. How? Okay. What is the answer for F if my input A is 1, my input B is 0, and my input C is 1? What do you think the
No?
Yes, yes.
The answer is 1.
Ui, lajunya. I also, I also don't know. Let me try. Okay, the answer is 1. 1, 0, of course, is going to be 0. And then here is 1, or at least 1. That is okay. And then over here, you will get 1. Output is 0. Here is 0. But you can see the O here. At least if you have 1, then you will get the output of 1. So correct. So this is what you're going to like apply later on. But this is very simple circuit. Later you will have like more complex. And in next slide, you're going to see the Boolean expression. Okay, thank you for answer and congratulations because it's correct. Now you can see there are a Boolean expression. What is the Boolean expression? It is more like a mathematical equation, but it is only for digital logic equation. That's why it's called as like Boolean expression for the equation for the output. Let's say we take a look first at these simple things. Okay, we have buffer. What is buffer? There is like nothing happened there. There is no bubble for buffer, which is whatever input, the output also similar. Whatever input, the output will be similar. And if vice versa, Google Drive. Okay, if another one more thing, which is after you have like direct, which is buffer, you will have also not. So this part is positive, this part is negative, which is not. And you will have 0, 1, 1, 0, which is whatever input you will like vice versa. And for this part, if you have the input A for 0, A for 1, your output also will be similar to the value. That's why, let's say your output is F, F equal to A. Because whatever A value, your output also is similar. But if for NOT gate, your output will be different or toggle from your input. So your input is A, because it is toggle, we put bar over here. There is a bar. So we call it as a bar, and it is a toggle value or inverts value from the input. Okay, next we look into our N. Our N we already know will be 1 only if both of these input is 1. And this condition, if you look and go through over here, you will see that the situation is like multiplication. If you multiply with any 0, your answer will be 0. But when you multiply with 1, it will be the similar answer to your the value that multiple with 1. But of course, you're going to have only 0 and 1 for the digital logic or Boolean expression or any kind of DL, because there is no casting in between of this value. So you can see, oh, it's more like a multiplication. So it's similar to multiplication. That's why it will be A dot B. But we were too lazy sometimes. Normally, we will just put A, B. So you need to know AB is similar to A dot B. Because we don't want like to put, let's say you have 5 input. Is it okay to put like this? So instead of having all the dot in between, we just like putting like this. So this is as long as like it is like close to each other, it is a dot. So it's going to be like 1, 2, 3, 4, 5. A, B, C, D, E. This is your X. Okay, now once you already know about this Boolean expression for our AND gate, let's take a look how if let's say uh, if let's say you're going to have the NAND. Where? And you can see if let's say you have A dot B, when you have a NOT, this is basically NOT AND. And the combination of NOT and AND we call is as NAND gate. We call as NAND gate. This is NAND gate, basically look like this. Why I want to draw is below. So because of this, I can combine it directly together, remove this part, I put a bubble here, and I have and got my new gates, which is called as NAND gate. And my NAND gate, okay, if for my n, I have x equal to A dot B, or it can be A, B. So apply similar things to my NOT. I need to put bar as all the input will be bar after that. Because you can see over here A, B here, after that is go to the NOT, it will be bar everything. It is not this one A, B bar. It is not A bar B bar. This is not similar. So please make sure you see carefully on the bar, because there will be always a questions for you to like simplify the Boolean expression using like several method. There will be a method for you to learn, but throughout you need to know all of this, which is A, B bar is not similar to A bar, B bar. I give you the example. What is this one? You already know it will be So this is the circuit for this one. But for A bar dot B bar, it will be like this. A, this is your A, and you will have bar. A, you will have bar, and then B, you will have bar. Then you're going to meet your multiple here, so that there will be multiplications A bar dot B bar. So this is gate N, and this is your circuit for this one. So it is not similar. Now let's take a look on the table. After you're done with these things, you know that, oh, NAND gate is totally different. It is like a toggle, or it is like inverter for the AND gate. So of course your output will be all toggle and all invert from the AND gate. So when you have 1 1, it will be 0. The rest will be 1. Similar to this part, everything will be 0 only when you have 1 1. So it will like inverse for AND gate and inverse from the AND. Now we will have our next, which is OR gate. Our OR gate, it more like, oh, if I can see is 0 plus 0, it will be 0. 0 plus 1, it will be 1. 1 plus 0, it will be 1. 1 plus 1, it will be 1. It is not going to be 2 because you only have 1. But basically what is happened here, 1 plus 1 will be 1 0. Why 1 0? 1 plus 1 will be 2, right? But instead in our binary will be 1 0. 1 0 is to the power of 1 to the power of 0, and total you will get 2 in decimal. In this one is in binary. So 1 plus 1, this one is your value and this is carry. But all of this you will learn in your numbering system. I just want to inform you first why you can assume it to be plus over here. That's why you will like remember the Boolean expression with the truth table. So now for O, it's more like adding. Whenever you have at least one input, you will have one. So this part you already look. And of course, as I mentioned, this one all is not. You will have not or. Combination of not or, you will get no. No get here. So it will be look like this. You will have or get, and then there will be not get, and it's combined, it's to be or get. For this or get and no get, you will also see it will inverse everything here, and the value will be inverse 1 0 0 0. So please make sure, if you don't want to memorize this table because you said there is too many things that you want to remember, as long you need to remember the 3 basic, which is your AND gates, OR gates, and NOT gate. You will like say, okay, for NAND gate, first I draw the truth table for AND, and then I draw OR gate, and then I inverse just to get the value for the output. But it's good also for you to like direct memorize the situation for the NAND gate and also NOR gate. As you can see over here, you also have this kind of gates. What is this gate? You can see it is X, O. X we assume is to be exclusive. So exclusive O, it is very exclusive gate. This is the symbol. You're going to have like similar O over here, but there is another curve which is look like X, and this is exclusive XO, and then you have B, and this is X. And it will be a slightly different situation. You will only get the output is to be 1 if only at least only one the input is 1. If both is 1 also cannot, only 1, then you will get the output as 1. So this is the true table for the XOR gate. And similar to the rest of the gate, you can also have the node, XOR node. You will get X no. So similar, you will inverse everything and it will be look like something that you put bubble. Let we see. So this is the looks, and this will be the inverse from our XOR. And because this is the Boolean expression, and everything will be bar. Similar to our no, we will bar everything, and it's not going to similar like A plus B bar equal to A bar plus B bar. No, it is not similar. So over here also, if you have like A, B bar, it is not similar to this. So please make sure you know this. And everything before you can move forward, you need to understand and remember all these basic things, not only for the symbols, not only for the table, but also on the expression. Later on, you will be apply something like this. Okay, let's say you have your output is, let's say, F. You will have A, B bar C plus A, B bar plus B bar like this, maybe A, B bar C plus A, D plus D bar. Okay, when you look over here, you need to see all the variable. In this like case, you will have 4 input. Although sometimes over here there is no enough, like there is no D, only at the end 2 over here there is D. But supposedly when you apply something like pause SOP, you will notice that you have also D here, only you factorize and simplify. That's why you cannot see. So 4 input for this circuit, and you need to like make it more simplify, more simple for this equation, or maybe you were given only this equation. Please draw a simplified versions of circuit. So you need to simplify this Boolean expression first, and then you can draw. Maybe at the end of this, you will get like this output, or maybe you will like have these 3 And then or maybe you have A, C, D, here is B. So it depends how you simplify those long sentences, long Boolean expression. So please make sure you understand and memorize now. Okay. So next subtopic, this one, you can see there is a logic function. This is only function. So what I want you to do, I'm not going to teach in class, but I will record a video. I will pass you to the e-learning. You need to watch the video. And in this slide, the notes that I uploaded into your e-learning, slightly different, not different, but only few. In like our module is much more like advanced, and there is a lot of like example and exercise, so please try to do read there also. You're going to look into comparison, but a comparison for like comparator, and the function only you will look into this module 1. Later on, maybe at the module 5 above, you will create your own module for comparator, for counter, and many others. You will see that you need to create your own calculator and so on. So for here in our module 1, you only see the function. What is the function of comparator? So you will see, let's say you have two binary or two inputs, then you will compare the value of A and B, whether it is more or maybe it is similar or it is less of value. So this is the function of comparator. Then your output will be either this one or maybe similar. It depends on your circuit inside. So you are the one that need to do the circuit later on. And sometimes you will be asked on project. You were given certain scenario that you need to create your own comparator. And this one is similar. Only that sometimes for your comparator, there will also additional circuit outside. So your condition also sometimes will be different. My battery is low. Okay. Did it detect? Okay, now you can see this is the like several function for comparison or comparator. And you can also have arithmetic function which is similar to your calculator. Your adder, you will add value of A and B. This one is the one I mentioned, there will be a carry. Let's say I give you example. Your input value maybe will be 1, 1. Let's say, okay. Maybe you're going to have like only 1, 1 for your A. And your input for B is 0, 1. So what you need to do after you like give the input, feed the input to your adder, you will get the sum, and your sum will be like a normal mathematics. You can see 1 plus 1, you will get 0, and you cannot put your 1 here. Your 1 is the carry, so you need to bring up carry 1. 1 plus 1 again, 1 is your carry. You will get 0, 1 plus 1, 0, 1. So this will be your sum. Because if let's say you are using 2 digit for your adder, your output will be also similar to, but you will have another additional over here to be your sum. This one is you're going to learn later on, but just want to see overview of the function. And then you're going to see also you will have like separator, multiplication and division. And normally you will create by your own self. Okay, this one is also similar. Not only that, you're going to also notice that there is several other numbering system, not only for like number A, B, 1, 2, 3, 4. This is all number, but instead you're going to see also variables in the codes of number function, including the ASCII code. BDC is, I guess, in numbering. So there is several others that you need to know. You can see there is others codes in numbering. And instead having the adder, the comparator, you will also have like full adder, add multiplication, multiplier, subtractor, and so on. But you will also have encoder and decoder to code and decoding function. So this is like example for you to see how the encoder look like and also decoder, where you going to apply it. For the encode, you're going to see you put the value directly in decimal, and then you will encode it to be binary. While for decoder, from your binary value, you will get the output of decimal, but this one, it applied to your 7 segment display. Let's say you have this is your 7 segment. You will have 1, 2, 3, 4, 5, 6, 7. That's why it will be called as a 7 segment display. And all of these are connected to the input. So this input, let's say, I just give you an example. Let's say it's the value for this one. This is the value for this. This is value for this, value for this. So let's say I have 1, 0, 0, 1, 0, 0, 0. A number. Maybe, okay, it's okay. So you can see you will have like this. For here you have like this, or maybe for this part I also make it 1. And over here maybe I will make it 1. And another one is 1. So your 7 segment will be like 3. So this is how basically you look at your calculator. You have multiplication, or you have several 7 segment, isn't it? Sometimes you have like very long calculator. So inside of it, there will be a 7 segment display, and each of that having their own decoder. So you cannot see like, oh, calculator, you just like simply press and press, but basically inside of this is like very complex to develop. And next, you're going to look into the function of mark and demarks. Please go through and read the function and example where you're going to apply your demarks and marks. in your module that you buy. And you will also look into the data storage, but it is only function for your module 0, for module 1. And counter. For your counter, sometimes also in your project, I don't know this semester, but there will be also a possibility for you to create a counter. Where you're going to apply your counter, it is normally in your day life activities, which is traffic light, washing machine, vending machine, zero machines, although you just simply see, oh, that is traffic light. But basically, it's come from digital logic. And it is using gates from basic. And gates also, you're going to like having the chips or IC to create all of these traffic light, vending machine, and etc. You cannot see this and you cannot play around with all these chips, all these electronic things this semester, but when you come to UTM next semester, please try to go to the lab and ask the permission to play around with the electronic things. And this semester, please make sure you already download the DIT simulator. Oh, I also forgot to upload this software, but you can find it in Google. It is free for you to download the DIT simulator and play around with the gates. Play with the output, play with the input value. You can like always change the input and then you can see the different to your output. It's very nice to play. And for your IT package over here, you're going to see that there will be something like pinch or notch over here. In this picture, you cannot see it. Wait, okay, this is much more clear. You have this kind of pinch, but there will be a circle there. Then you need to start to calculate your pin from the circle over here. So this is the first pin. We call it as pin 1. So there is several way for you to name it. You cannot just simply, okay, I want to rename it as 7 because I start from here and then I start from here. So you cannot do that because we already have the standard. It will be like clockwise over here. When you start 1 at this beginning, you will follow the clock anti-clock, and you will like continuous 8 to 9 here, not like 8 jump here to be 9. No. Similar to this kind of IC, you will start over here. It will be 1, 2, and then anti-clockwise over here. You can see 5, 6, 7, 10, 11, 12, 15 until the rest. Depend on how many legs you have, you need to know, because sometimes just a simple question for you, 1 marks question, what is the pin here? So you need to know it is like 16. If you cannot know, it's like didn't give you any value over here. Of course, it's just pointing up to this. What is the pin for here? So you need to find the circle, start calculate it. This is all the example of, if you don't have, basically you will have like this bubble, but maybe the picture is not clear. You can see maybe somewhere over here, but you sometimes you will have the notch like this figure you can see, and you will start from your left side. Here, okay, this is our pin 1, 2, 3, and so on. It will start over here. And you're going to see that this is another example of your IC, and where basically you apply this your IC to, and there will also another additional, which is CMOS, NMOS, and this kind of question will be coming out for your part A. Last semester it will be asked especially from your module, so please read and go through your module books. Another one is programmable logic device, your PLC. Your PLC, there will be several type of PIC. You're going to have SPLD, CPLD, FPGA, and so on. So that is only for module 1. No worries, I will make a video for this module 1 for the function, but please make sure you go through everything in your module books. And next class we will go to our module 2, which is on numbering system. So then in this numbering system, that's why you will see all the best. Binary, decimal, hexadecimal, octal. There will also another best 3, 4, 5, which is we not cover in our digital logic, but it is available. So as long as you know how to play around with numbering and how you can come up with the numerals representation for each base number, then it's easy for you to like convert any kind of numbering system. Okay, until here, is there any question from your side? No question?
So far, no. Betul.
So far so good. But although it's so far so good yesterday, you still cannot get full mark for your simple quiz today. What happened?
Careless, madam.
What? Miss
Careless.
Careless. Okay, it's okay.
Nobody perfect.
I will go through your quiz later on, but please make sure check back all the videos that I uploaded. Your video yesterday I already upload to the YouTube, but is it in e-learning I already upload or not? Yes.
Already.
So please make sure you go through after class just to make your understanding more full, like increase, and no need for you to like study last minute. Okay. We will end our class for today. Meet again next week, Monday. Till then, please be safe, stay at home, and goodbye. Bye bye.
Bye-bye. Thank you, madam.
Bye.
Thank
you, doctor.
Bye-bye.
Thank you, Doctor.
Thank you, doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you.
Okay.
Thank you, doctor.